8th graders, it's Mrs. Thompson again. We're going to jump back into 5.4 example 2. What I showed you in example 1 were the possibility of having a system that never intersects ever because they're parallel lines and you won't have actually any solution at all. All the systems we've been doing in sections 5.1, 5.2, and 5.3, all of them crisscrossed at some point. Well, in example 1 of this particular section we're in right now, I showed you when they don't intersect, okay? Because it is possible to graph or have two parallel lines, and of course we know that they don't intersect. So now we're going to talk about systems that have infinite solutions. Infinite solutions. So what does that look like? And again, we're back to our 3 strategies, comparing the slope and the intercept. You could graph them. Okay, I'll talk about that. I'm actually not going to graph it, or we're going to solve it algebraically. So I'm going to do the first strategy and the third strategy again, like I did in the other ones. Okay, so let's start with strategy 1. We want to do M and B. We want to compare the M, which is the slope, and the B, which is the y-intercept. Now, in the first equation, that's in slope-intercept form already. So that's in a good form. We can clearly see M is 2. And B is 1, okay? Really easy, great form. Second one is not in any kind of form. It doesn't look like, close to standard form. So what we want to do is we want to get y by itself. So why don't we just add y to each side, and that will get y all by its little lonesome, because 0 plus y is y. And now it's slope-intercept form. Here we got M is 2 and B is 1. Now, we want to compare the slopes. The slopes are the same. Both of them have a slope of 2. But they also have the same y-intercept of 1. So when you have the same slope and the two lines crisscross at one point, so you have one solution, whatever the name of that point is, or they're parallel lines and they never intersect, so that's a no solution. Or here's your third possibility, that it's the same line graphed on top of itself, and so you have infinite solutions. Okay, so my only comment about graphing, if you graph it, what you'll notice is it's the same line graphed on top of itself. That's what it's going to look like if you were to graph these two lines. That's what it would look like to you. You'd be like, hey, it matches up everywhere. It doesn't, every point I draw with my line is covered. So that's what you're going to see there. Okay, let's look and see how it looks solving it algebraically. All right, I'm going to keep the slope-intercept form, and I'm also going to bring the other slope-intercept form from the second one, the one I rearranged, okay, which was the 2x minus y plus 1. This is what I rearranged it to. So if 2x plus 1 is another name for y, and 2x plus 1 is another name for y, then they must be equal to each other. Okay, now look, you have the same exact numbers on each side. You have a 2x plus 1 on the left, you have a 2x plus 1 on the right. So you could stop right there and go, hey, they're equal, they're the same. So this is an infinite solution. So you could pick it up right there. But if you don't, then what you could do is go ahead and try and solve for x. What you'll notice is, hey, they cancel out. I have 1 equals 1. Well, here's what you ask yourself. Does 1 equal 1? Yes, this is true. That is absolute truth. 1 does equal itself. So you go, oh, this is the same line. So my answer is infinite solutions. Okay? So that's what we're getting to. I'm trying to get you to see that there are 3 possibilities for answers. Either the lines crisscross at one point, or they don't crisscross at all because they're parallel, so we have no solution, or it's the same line graphed on top of itself, so all solutions, infinite solutions exist for that. Okay, so that's example 2, and hopefully I made perfect sense. Just let me give you a little kind of a side note. If you flip back to the front page, we had some vocabulary here, consistent and inconsistent systems. And so I wanted to just draw your attention to inconsistent systems. It's the bottom one, inconsistent system. It's a system with no solutions. So that would be example 1. If I were to classify that solution, my solution is no solution. If I were to classify it, I would say this is an inconsistent system because there's no solution. The only way I know it's inconsistent is I solved it, found out that it had no solution, and therefore it's inconsistent. Okay? Now let's flip to page 2. Okay, I have infinite solutions. Well, if you remember from page 1, I'll flip back again. A consistent system has 1 or more solutions. Well, when you have infinite solutions, that's the or more in that. I have 1 or more solutions. So I would classify these systems as being consistent. Okay? This is a consistent system. So if I have a system that has just 1 answer, it is consistent. If I have a system that has infinite solutions, it is also consistent. And if it's like example 1, I have no solution, I would classify that as inconsistent. Okay, hopefully I made perfect sense. I'm sorry if I didn't. And please bring your questions to class tomorrow.